Hello, I am doing some inverses today. On this page of my notes, I've already done two problems. I'll quickly go over them, but since they're comparatively simple, I'm not going to be doing them slow-mo, basically. How to find inverses algebraically. I put them here in a couple of steps. First of all, if it's in the notation f of x, I'll just change it to y. It's a little bit easier to not have to copy down f of x every single time. But anytime you're doing an inverse, the number 2 here is the most important thing to remember. What you do is you are going to physically switch the x and the y, and then you'll resolve for y. So like in these ones, I changed it to y, but then instead of y equals negative x, it was x equals negative y, and then you solve for y again. Same thing here. It would be x equals negative, change that to a y plus 1, and then you would solve and do stuff in order to get y by itself, and you get your new function. So these two are comparatively straightforward, so I'll just leave it to you to look at them if you need to again. But going down to number 3, you are going to change this to a y, and then you will switch the x and the y, so it says x equals 5y squared minus 4. And you go through some algebra stuff to get y by itself. So you're going to have to get rid of the 5, the 2, and the minus 4, and you have to know what order to get rid of them. And once you get rid of all that stuff, then you will have your answer. In this case, the first step is to add 4, and you get x plus 4. Not like terms, so you can't really do anything else. After that, getting rid of the 5 or the 2, you need to get rid of the 5 first, to cross out like that. And same thing here, there's nothing really to simplify. You just get x plus 4 over 5 is equal to y squared. And then for the final step, you would need to square root both sides in order to get y by itself. But the thing is, since you square root both sides, you are supposed to put a plus or minus in front, and you would get this, which there's two things I need to say about. First of all, is if I give you a question like this, or anyone gives you a question like this and just says to find the inverse, please make sure you are putting everything under that root, including the 5. A lot of times I'll see people write something like the square root of x plus 4 and then over 5. This is not acceptable. This is saying you're square rooting the top but not the bottom. So you have to make sure it is square rooting the entire thing when you write it. But besides that, the other thing I have to mention is that because of this plus or minus, this is technically not a function. And I don't know why I'm using the word technically. It is not a function. So using the whole like f inverse thing doesn't mean as much as it used to because it's not an inverse function. But this is what you would get. This would be the inverse relation because you can take the inverse of any relation, really. So that's what you would get. Over here, something similar. You get x equals negative 3y squared plus 5. It's pretty similar to the previous one. I would suggest pausing the video for a second and see if you can get it yourself. Otherwise, here I go. First step, subtract 5. Second step, divide negative 3. And you get x minus 5 over negative 3 equals y squared, because those cancel. And then square root both sides again, putting a plus or minus. So you would get y equals plus or minus the square root of x minus 5 over negative 3, like that. Okay, and that would be the answer. There's technically more stuff you can do with this. To simplify it, like a lot of times people will not want you to have a square root of bottom so you can rationalize the denominator, but that's all I'm going to go for right now. Okay, in this next section it says to find the inverse continued and state the domain restrictions of each function. And basically there are two types of domain restrictions that we are going to worry about in this section. There's more in other types of math, but for what we're going into, the scope of this course, there's only two. And neither two actually comes up in this one. It is 5 minus x to the third power. There are no domain restrictions of anything to the third power. If you were to look at the graph of an x to the 3, it looks something like this. So like the domain is all real numbers, the range is all real numbers. There's no restrictions. It also passes the horizontal and vertical line tests, so everything is going to work. But if you don't know off the top of your head, it's not a big deal, because as I said, we're only going to go over two things that have domain restrictions, and you can just physically see that neither of them will apply. So here, we're just going to do the same thing as before, x equals 5 minus 2y cubed. And you will get y by itself. Feel free to pause the video and try it, and check your answer afterwards. Otherwise, here we go. You need to get rid of the 5, the 2, and the 3, and it turns out we actually do it in that order. This is a positive 5, so you subtract 5. This is a negative 2 times y, so you divide by negative 2. And you get x minus 5 over negative 2 equals y to the third power. And in the last step, you would cube root both sides, like that, to get, there we go, to get y equals, or if we want f inverse equals, just this whole thing, cube root of x minus 5 over negative 2. Note that you do not need a plus or minus in this case. You only need pluses or minuses if it's like an even root, like a square root, a fourth root, a 6, an 8, a 10th root. Those require a plus or minus, but any odds do not. Okay. Here is the first example of something that will have a domain restriction. And I'll write them over here on the side, the two types. You can actually see them. These are the two types right here. So first of all is even roots, which most often you're going to see square roots. There can be fourth roots, sixth roots, eighth roots, any even root, but most specifically square roots happen the most in our unit. You are going to have a domain restriction. And the other one down here is anytime you have a fraction with an x on the bottom, specifically on the bottom. So I'll just write that down. And there you go. The thing about roots, square rooting, there's a certain type of number that you cannot square root, and that is negative numbers. You cannot square root negative numbers without getting like an I, but we're not going into imaginary numbers right now, which means like I could take the square root of 3, I could take the square root of 9, I could take the square root of 0, but if I asked to take the square root of negative 4, you can't do that anymore because you cannot square root negatives. And in math, the way you say, well, I should say this first. You want to say then that I can only square root positive numbers. And in math, there's a specific way to do that. And if you think about it, it's like, if I'm talking about positive numbers and I'm talking about negative numbers, there's a certain boundary where it starts being positive and ends being negative. And hopefully you know what that boundary number is, where between positive and negative. It's 0. So if you are talking about positive numbers, you want to say that these are the numbers that are more than 0. Or as they write in math, x is greater than 0. So if x is greater than 0, you're talking about positive numbers. But as I said, you are allowed to square root 0. So it can be anything greater than or equal to 0. And I'm using x right now. Maybe I shouldn't, because you're not going to be setting x greater than or equal to 0. Because in this case, this is the square root stuff. The square root stuff has to be greater than or equal to 0. So like in this example, it's the 4x minus 7 that is going to have to be greater than or equal to 0. So you just go 4x minus 7 is greater than or equal to 0. Because this says it's positive. 4x minus 7 is positive. It happens on the SATs a lot as well. If you ever see less than 0 or greater than 0 on an SAT, they're just saying it's positive or they're saying it's negative. That's all it means. Whew. I just said a lot of stuff. Break time. Whew. Okay. Solving this, add 7, divide by 4. And you get x is greater than or equal to 7/4. That is the domain restrictions. Boop, boop. Domain restrictions. X has to be greater than or equal to 7/4. Otherwise, you switch the root of the things, and you get x equals the square root of 4y minus 7. The opposite of a square root is to square, so you square both sides, and you get x squared equals 4y minus 7. Add 7, and you get x squared plus 7 equals 4y, and you can divide by 4 to get the answer. Y equals x squared plus 7 over 4. Once again, though, you have to keep both of these in mind. They go together hand in hand. This is the inverse, but it only works when x is greater than or equal to 7/4. On a different part of this, you will see graphically why that has to be true, but that's what it is right there. So here, we'll do 8 first. The other part, like I said, is when there's a fraction on bottom, and that has to do with that you cannot divide by 0. Whoop! Exclamation point, because it's important. Since you cannot divide by 0, that means the bottom right here, it cannot equal 0, because if it did, you'd be dividing by 0. Ooh, look at that. That's awesome. So if you solve for this, you would subtract 4 to get negative 2x does not equal negative 4, and you would divide by negative 2 to say x does not equal 2. And that would be your domain restriction. If x was 2, then you would have 4 minus 4 is 0, and you wouldn't be able to do that. So 2 doesn't work.